Hey guys, it's Casey from the Montreal Student Network, and today we're going to be looking at the names of the first 20 hydrocarbons. I made you guys a little list over here, and to make sure you can see it clearly, like all my videos, I record them in HD, so to have a crisp font, you should watch the video in either full screen or the enlarged screen option available in the bottom right-hand corner of the video, and also put it in 720p. That will give you guys the best viewing experience you can possibly have. So, like right now, I have a little graph or a chart that I made you guys having three columns: the number of carbons, the name, and the formula. Now these formulas might seem a little bit intimidating, but they are all relatively following the same concept that carbon can only have 4 bonds attached to it. A alkane hydrocarbon only has carbon and hydrogen. And these names are referring to straight chain carbons. So a straight chain carbon would basically have 3 or whatever carbons. So let's just start off with 3 for propane. Carbons lined up in a straight line. If you want to have 4 carbons, you can have 4 carbons. You want to have 5 carbons, you can have 5 carbons, but they're in a straight line. They're not branching off like this. You know, that would not be considered a straight chain alkane. We're going to be getting into different alkyl groups when we are talking about that. So let's get rid of that. So let's stick with this 5 carbon compound, which we can look in our list and see that that is actually pentane. Now looking at the formula, we have CH3, CH2 open bracket or in a bracket with a 3 subscript, and CH3. This refers to having 2 CH3s on either end, and in the middle you have 3 CH2 groups. Now we know that carbon can only have 4 bonds. So the carbons on the end, which are only attached to one other carbon, can have 3 carbons, which make it a CH3 or a methyl group. But since it's attached, it's all at one, we wouldn't really refer to it as a separate group. We'll just, call it a CH3 part or an end carbon right now. The ones in the middle are attached to 2 other carbons. So those can only have 2 more bonds to get the 4. They'll have 2 bonds to hydrogen, and those will be all CH2s. So let's draw those out right now. And there we go. We can get the color. We can see that right over here. That's CH3. Right over here we have CH3. And in the middle we have, like our little subscript for pentane indicates, we have 3 CH2 groups. And this will always be true for no matter what straight chain you're looking at. So you don't need to concern yourself with all these intimidating numbers in the formula column. It's really just referring to how many of these guys you have. See how we have 3 of them? I can circle them all right now. There we go. So 1, 2, and 3. And then we have our 2 ends. You always have to have your ends. So that's the basic formula that we're going to be following. So don't really concern yourself with this column. You're really going to want to concern yourself with the name of this one right here. So starting off, having 1 carbon is a methane. We've heard of methane before. I'm sure you've heard of that in real life. It's what composes your farts. Number 2, ethane. Another thing that you've probably heard about. 3, propane. Propane's obviously found in commonly found, in barbecues. 4, butane. It's another source of fuel that's often found in lighters. So those are ones that you've probably heard about before. You probably haven't heard of pentane or hexane or heptane. Maybe you've heard of octane before. I've heard of octane before, but all these other ones besides these first 4, I've never heard of before. So we need to find a way to associate them to try to make it easy to memorize. Trust me, these first 4, after you do a lot of practice problems, I know in the book that I'm using, which is Organic Chemistry 8th edition by Francis A. Carey, just by doing a couple practice problems and the problems associated with the content in the book, you're going to know these first 4 very easily. So don't put too much time into memorizing it right now. You're going to know them just by doing the problems. And, just by looking at them right now, methane is 1, ethane is 2, propane is 3, and butane is 4. And then just by using that simple carbon can only have 4 bonds and everything arranged in a straight line theory, you can obviously figure out the formula without memorizing it. So don't memorize the formula, just know the rule behind the formula. Moving on, the ones that might be a bit more confusing are pentane, which you can just think of the prefix is pent, and the ending is always ANE. Like it's an alkane, it will always have ANE as an ending, no exceptions. So pent, think of a pentagon. It has 5 sides. Think of a pentathlon, has 5 events. This will have 5 carbons. Hexane, similar. Think of a hexagon, and trust me, you're going to be doing a lot of hexagons in organic chemistry. If you've already been introduced to the cyclohexanes, that's pretty much going to be the whole course right there. Hexanes will have 6 sides. A hexagon will have 6 sides, so hexane will have 6 carbons. Likewise, heptane, a heptagon has 7 sides. Heptane will have 7 carbons. An octagon, or like a stop sign, has 8 sides, so octane will have 8 carbons. Oct. Always think of that at beginning. Then moving on, I was never introduced to the shape that has 9 sides or a name for it. I'm sure there is one, but I was never introduced to it. So for something like nonane, I just thought of the word 9. Now I'll just draw it out here on the side. 9. Word 9, it has 2 ends in it, just like nonane has 2 ends in it. Little associations like that, maybe it doesn't work for you, but something like that works for me. And just little thing like that to remember it, and boom, I will never forget it. And then I don't need to think, what was my trick to remembering it. Once I've established that first trick to memorize something, I don't need to think of the trick anymore. I'll always have the content memorized. So it's just getting that initial memorization done. I mean, if you want to just look at this list and grind it out, you can go ahead and do that too. I'm just going to try to offer some extra tips. If you were going to think that 9, you might get confused with ninane. It doesn't sound that great. Nonane, it sounds legitimate. So, little things like that. Moving on, let's scroll down a bit to the ones that are 10 and up. Now 10, it's still technically part of like the first group that I was showing you guys where I had the green prefixes, but this is one you're just going to want to memorize because knowing 10 will allow you to know all the way up to 20 or up to 19. 20 is a little bit of an exception. So decane. Memorize this. This is one word you just want to know because this will give you the opportunity to know up to, go up to 19. And it's just by memorizing decane, it makes the rest really simple because you can see all the other ones. 11, it has decane. 12 has decane. 13, they all have decane as the ending. So all you need to do is now know the beginning. And now you're going to want to make it look like an addition. You're going on 1 plus 10 is what? Decane will represent 10. UN, in French, that represents 1. If you know French, UN means 1. So that will be 1. So you can just think of it, just breaking it down into a bit more simple. 1 plus 10 is 11. 11 carbons. Now, there's no breakdown in the chemical. When you're actually drawing it out in bond line, it's still going to look like one big straight chain. Just for the name, we're going to be breaking it down. So make sure you know decane represents 10. I'm sure by just me saying it over and over, you probably have it in your head already. So moving on, the first two just are a bit different than what you would normally know from the Greek prefixes that you'd use, say, when you're naming covalent bonds, because like carbon dioxide has 2 oxygens in it, so we call it dioxide. The di, that's a bit different. It's not called didecane, it's dodecane. So these two are kind of exceptions. Maybe those are ones you're just going to want to put a bit of extra time into. But after we get to 13, it follows that same pattern that we know before. Tri. That's a common indication of 3. So I just colored all over it. Tri. So tridecane. Once again, we are going to be thinking of 3 for tri plus 10 for decane. 13 carbons. And we're going to keep following that pattern. Tetra, it's a term we've learned in general chemistry and we've learned in high school chemistry. Tetra indicates 4. Penta indicates 5. Now here we can, thinking back to what we were doing before, let me just scroll up. It does have kind of the same, prefix. Pent, penta. Hex, hexa, except we have the A. Now, if you're going to think you're going to forget the A, because it is similar, you can kind of cut some time by, realizing that you studied it before. Just think, pentdecane doesn't sound good. Pentdecane. Does it sound right? No. Pentadecane, it sounds good. For me personally, I cannot say pentdecane in one word. I have to stop in between to change the way I'm talking. Pentadecane, it just rolls off the tongue. It works. It might seem like a weird way of knowing it. Maybe you don't think it's not a really professional way of me explaining it, but honestly, it's what worked for me, and hopefully it works for you guys. Now we can see we follow that pattern: penta, hexa, hepta, octa, and nona. It's the exact same ones from before. with the added A and the decane. So remember, now we need decane. Tetrane, it doesn't even sound right. So you don't need to really concern yourself about forgetting the decane. Just know that once you pass 10, going up to, you shouldn't know past 20. Most teachers will not ask you to know past 20. Most teachers probably won't even ask you to know past 12. Make sure you ask them so you don't study stuff that's, not necessarily important and then end up confusing yourself later on. And the last one finally is icosane, which is 20. It's a little bit different. There are a few ways of saying 20 carbons. Icosane is the one that was written in my textbook. I know there's some other options out there. That's just a little exception that you're probably just going to want to, study. There's really no trick to it as far as, that's available to me on hand. So that's just one thing you're going to want to memorize, icosane representing 20. So this, and it will have the exact same thing. I'll draw out the bond line for you guys just so you know that you see it's CH3, which means you'll have your N carbon and CH3 on the other end. And in the middle, you'll have 18 CH2 units. And you're going to draw it out the exact same way as you would draw any other one out. So we'll start off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now, if you're wondering why you always draw these in a zigzag line, that's the technical way of doing it, because obviously, look, you can't just draw it out in a straight line. I mean, how are you going to know where carbon 1, 2, and 3 are? So doing it in a zigzag indicates, carbon 1, carbon 2, carbon 3, all the way over here to carbon 20. I will just spare you guys the time, and I'm not going to number them all. And like before, following the exact same pattern, this one on the end is an N carbon, CH3. It's only attached to one other carbon. It needs to have its 4 bonds. So there we go. And this one over here, CH3. And every one in the middle, so we take this one here, any single one, CH2. This one over here, CH2. There's 18 of those CH2s. Follows the exact same pattern. So do not concern yourself with knowing the big formula right here. So the list is available for you guys right now if you want to just go back to the start of the video before I started coloring all over it and look at it. All the information here, it's all organized neatly, and hopefully it helps you out. If you have any questions or you want some more tricks to memorizing this stuff, send me a message on here in a comment or send me a message on Twitter, and I'll get back to you guys as soon as possible. So thank you very much for watching. If you want to see more organic chemistry videos, please check out the Montreal Student Network. My name is Casey, and I hope you enjoyed the video. Have a nice day.